Here we go with section 1.5. We're wrapping up unit 1 on dealing with functions and their graphs and finding out all the basics of functions in general before going to specific functions. This function section we're looking at inverse functions. Oops. Here we go. So first I want to just practice using this idea of composition of functions. So here it's functions f and g, and I want you to evaluate the composition at 10 and at -4. So pause the video, give yourself some time, try to work these out, then start the video up again, and we will work through these. So for f of g of 10, we're going to start with the function g of x. So we're going to say g of 10 is just you plug in 10 for x, 2.5 plus 0.5 times 10 is going to be 2.5 plus 5, so that's going to be 7.5. So since that's g of 10, now we're going to plug that into function f. So we're going to do f of 7.5 is 2 times 7.5 minus 5, which is 15 minus 5 equals 10. In this one here, we're going to start off with f. So we evaluate f of -4, and that is going to be 2 times a -4 minus 5 is a -8, minus 5 is a -13. Now we come along and do our g. So we do g of -13 is 2.5 plus 0.5 times -13 is 2.5 plus a -6.5 is going to be a -4. So when you notice these two functions seem to work out, that when we do the composition, we plug in a number into g, and then we take the answer into f, and we get right back to where we started. In here, when we plug a number into f and take that answer into g, we get right back to where we started. And that's kind of what we're looking for when we look at this section, when we look at inverse functions. So let's look a little bit farther with what we're doing. Here's our learning targets. I can find the inverse of a function. That's actually going to be the last thing. Well, we're going to focus on this one first, but we need to find these inverse functions. We need to prove that two functions are inverses, and then we're going to look at graphing the inverse functions. So that's basically what we're going to be doing in this lesson. So what is an inverse? The inverse is kind of like the opposite. When we talk about in art, when you talk about inverse colors, we talk about opposite colors. So the inverse of black is white. The inverse of white is black. When you go with colors, you got to look at the color wheel, and then you're beyond my expertise, because I didn't do much with art. With math, it's much simpler. Multiplication and divisions are opposite. You know, if we multiply, whoops, wrong thing again. Get used to using this tablet here. If we take 5 times 3, we get 15. If we do the opposite of multiplying times 3, 15 divided by 3, we get back to 5. Where they're opposite operations, they undo each other. Same thing with addition and subtraction, they're opposite. So we call these inverse operations. The one function undoes what the other one does. When we're looking at squares and square roots, these again, a square is not necessarily an operation. Squaring is a function, and a square root is a function, but these two functions undo each other. Because if we take x squared and then we take the square root, we get back x, as long as x is greater than or equal to 0, because this will only give me an answer that's greater than or equal to 0. If we take the square root of x and we square it, we're going to get x. And again, x has to be greater than or equal to 0, but that's because you can't take the square root of a negative number, so it wouldn't work anyway. Those are inverses, and that's what we're trying to figure out what to do with functions. Oh. So going back to those two functions we started off in our warm-up, we're going to do this as a composition using x. We're not going to put a number in. Remember, this is our symbol. I got to remember that. This is our symbol for composition. So this f composed with g actually means f of g of x. So if we do this again, we're going to start with g of x. And here's my g of x. Well, I can't evaluate that because I don't know what x is. So when I come to my f of g of x, I'm going to just take my function f, and I'm going to plug in g of x. 2.5 plus 0.5x. So that's kind of what that composition is. What this means is I put this 2.5 plus 0.5x in place of the x in my function f of x. So I say I got 2 times this minus 5. Well, what this is, what my input is 2.5 plus 0.5x. Now when we work this through, I hit the wrong button again. That brings it back. 2 times 2.5 is 5. 2 times 0.5x is going to be x. And then we have this minus 5. And 5 plus x minus 5 equals x. So what this means is no matter what value x is, no matter what value I plug in, if I plug it into g and then take that output and plug it into f, they will cancel each other out and I will get right back out what I started with. And that's what we are looking for in an inverse function. We're looking for a function that will undo it, because we use undoing all the time for solving equations. So that's kind of what we are looking for. So we're going to start off with a discrete example here. F of x equals just these 4 points. So again, my domain is going to be 1, 2, I'm doing this again. 1, 2, 3, and 4 is my domain. That's the only things I can plug into function f. But here's my output, 5, 6, 7, or 8. So if I wanted f of 1, I would come over here and f of 1, if 1 is the input, 5 is the output. So f of 1 equals 5. If I want to get an opposite of this function, a function that undoes it, I want a function that if I input 5, I'm going to get an output of 1. So if I plug in 5, I want to get out 1. Now notice this notation I'm using, -1. You use that back in trig for things like the inverse sine of x equals theta. We did this. This is the same as the arc sine. That was an inverse function. So we use this notation when we put a -1 on the function. That's saying it's the inverse function there. So going with this idea, F inverse would be just switching the x and the y's. 5, 1, 6, 2, 7, 3, 8, 4. So that my inputs are 5, 6, 7, 8, and my outputs are 1, 2, 3, and 4. That would be a way to get an inverse function. And that's what the big idea we're doing here is we're going to switch input and output, because the input here becomes the output down here, and the output here is the input, and that's why we get the one undoes the other. So, kind of again, looking at this with the composition idea. If I want f inverse of f of 3, f inverse of 7, or would be f of 3 would be 7, and f inverse of 7 would be 3. Let's go here. So f of 3 would give you 7, and f inverse of 7 would give you 3. Same way if we did f of f inverse of 6, f inverse of 6 would give you 2, and then when you go to f of 6, or f of 2, that gives you 6. So again, the functions undo each other. They're opposites. That's what we use inverse functions for, to undo the function to get back to where we started. So here we can talk about this with a picture showing your domain and range. Let's see, what do we have here? Laser pointer, cool. So here with the function f of x, this is my input going to this output. If we have the function f inverse of x, this is my input, this is my output. You notice the domain of f is the same as the range of f inverse. And the range of f is the same as the domain of f inverse. So this is going to kind of put this in notes, kind of all these things we've talked about. F of g of x equals x for every x in the domain. Oh, let's get this out of the way. Of g, and g of f of x is x for every x in the domain of f. So we have to have both of these true in order to make sense. Because if you go back to these functions, the domain of f is 1, 2, 3, 4. The domain of f inverse is 5, 6, 7, 8. So they'd have different domains. So you got to look at, for each domain, which one is it still going to work. So we got to consider both of those. So again, the way we read this -1 exponent is for represent, and if we put that on a function name, that means it's the inverse function. So we would read this as f inverse. So f of f inverse of x equals x, and f inverse of f of x equals x. Again, your domain of f must equal the range of f inverse, and back and forth there. Okay, we're still going. Boy, this is a long one. In order to show that two functions are inverses, you need to show both that f of g of x equals x and g of f of x equals x. So we can do this by trying to plug in numbers. So, come on. Give this a try. Find f of g of 4, find g of f of 4. Pause this, do that work. then unpause it. When you do f of g of 4, you get 4. If you go g of f of 4, you get 4. Woohoo! Great! Now we're going to do it with this function. What if I try a different number? So if we plug in 3, give that a try. F of g of 3. Oh, I don't have it here. Here we go. Nope, I don't. When you do this, f of g of 3 and g of is not going to equal 3. And g of f of 3 does not equal 3. This works for 4. It doesn't work for 3. You cannot show by picking a number. I can't write too fast on this. Just like with those even and odd functions, we have to do it for x. Just because it works for one value does not mean it works for all values. So to show this, we need to do both of these compositions. F of g of x, show that that equals x. G of f of x, show that that equals x. So we're going to do that with this function here. F of x equals 9 minus x squared when x is greater than or equal to 0, and g of x equals the square root of 9 minus x. We got to be careful with these because this does not have a domain of all real numbers. So this is going to help us fix that. But let's go through and work this out. If we want f of g of x, that's going to be f of the square root of 9 minus x. So that's going to be 9 minus the square root of 9 minus x squared. So 9 minus the quantity, 9 minus x, which just gives me x. Woohoo! That's good. But now we also have to do it the other way around. So we go g of f of x is going to be g of 9 minus x squared. So that's going to be the square root of 9 minus x squared. So that's the square root of 9 minus 9 plus x squared. That's the square root of x squared, which will be x as long as x is positive. But we said here, this function f of x is only good if x is greater than 0, so we got that right. When we look over here, this works well. What if x is, not in this domain? Well, then we don't worry about it. Okay. Oh, I guess I have it worked out here for you. Oh well. This is a little clearer to see than what I wrote for you. But for no matter which way we go, the input and the output are the same. try with this one. Verify that these two functions are inverses. Pause this, and then we will go through and look at the work and see if you agree with what I got. Okay, let's try this out. So first we have to do our f of g of x. So that's going to be f of 3 over x minus 1. So that's going to be f is going to be 3 over x. 3 over x minus 1 plus 1. Well, minus 1 plus 1 is going to give us 3 over x. And then, again, to divide by a fraction, we multiply by the reciprocal. So that's the same as 3 times x over 3. And 3 over 3 cancels, and we get x. So that checks. F of g of x equals x. Now we'll try it the other way around. Let's get a big eraser here. Give me room to work. If I wanted g of f of x, I'm going to go g of 3 over x plus 1. So that gives me 3 over x is g. So that's 3 over x plus 1 minus 1. Well, this kind of gets nasty looking. But again, use this idea, we're dividing by a fraction. So I'm going to go 3 times x plus 1 over 3 minus 1. And the 3 times x plus 1 over 3, the 3's cancel. I get x plus 1 minus 1 equals x. And that works. So g of f of x equals 1. I'm going to stop this video here. We can pick up this, talk about the rest of this, which is looking at graphs and finding inverse functions, and we will talk about that tomorrow.